So I'm going to resume. This recording will then go on YouTube and will get shared far and wide. And you let me know when you want to jump to the next slide. And without further ado, I would like to introduce Harry. So my apologies if I mispronounced the name. Harry Seifert is the senior member of the IBM SAS Strategic Alliance team. Harry has been collaborating very closely with SAS R&D since 1998, with a primary focus on performance optimization. His work with the SAS Institute ensures that SAS software is optimized across the entire IBM technology stack that includes the power systems, flash storage, distributed file systems for SAS grid, and spectrum scale. He has worked with the customers, large and small, across the globe, bringing value to his clients through the enhanced performance optimization of their SAS implementations. And I know from some of the feedback for some of you people, Harry, you already worked with many people that on this call. So it sounds like many of you
that's great.
go back quite a while. So without further ado, Harry, over to you.
Okay, thanks, Vasily. So I want to just start this off by thanking everybody for joining and apologizing for the technical glitches. What we're hoping to achieve here is just to give you a real, high-level look about how we go about doing what we do to help optimize the running of large SAS routines. In this slide right here, we have a quote from one of the guys at SAS, Ken Gahagan, who is the vice president and the platform owner for all SAS R&D. And when it comes to what from Ken Gahagan's perspective, the difference in what separates our platform from the other ones out there on the market, it boils down to the physics, to the actual, the co-collaboration that we do with SAS that drives right down into our. Okay, so I just got the recording in progress message this past second. So go ahead, Vasily, and move on to the next one here, and we'll see if we can get through this.
Can you see the next slide?
Yes, I can. So in my experience, and I think we've already hit on it, and I'm happy to hear that there are folks out in the audience that that has worked with us on this. But this is just a short list of some of the challenges that we have when we're running SAS, which is, essentially a programming language, a 4GL programming language, which is a very, very powerful tool with access to data sources, spanning the globe. So SAS gives an ETL tool, and most of the time we spend doing a lot of things in SAS is doing the ETL, pulling the data from whatever source it's generated from, converting it to SAS data sets, and then reading those SAS data sets into the compute environment on your application host. And the biggest challenge I think that most of my clients have is how to reduce the runtime for a large SAS model execution. And I can tell you, based on some of the experiences I've had, we can send a query to SAS that can take days to return an answer. But often, in that case, by the time you get the answer, the question's no longer relevant. And in some cases, that happens in minutes, certainly not days. So speed to the end, time to solution is really what the focus that I've been doing for 20 years. What can we do to improve once the SAS user hits enter, how long it takes before he's got an answer from his query. And some of the things listed here are just common things that contribute to long running jobs, whether it's in the actual data step field, it could be in the infrastructure, which is what I am, by the way. I'm not a SAS programmer. I am an infrastructure specialist for SAS. And things like data quality issues, everything that's on the list here are just a few of the common issues that a lot of SAS shops run into. So Vasily, if you could please move to the next one.
Here it is.
So I wanted to just give everyone on the call here an insight into what we do with SAS and at SAS. I started working here in 1998. IBM opened what we called back then an International Competency Center. It is a jointly staffed and funded organization between our partner, in this case SAS, and IBM, where we literally put our latest technology in the hands of the ISV, this independent software vendors, SAS amongst many others, so that they have access to the technology and can develop some of their software routines around the capabilities of the technology. So you can see what we've done over the years. If we go back to Power 7 and Power 7 Plus, which is probably in the 10-year time frame back, going back 10 years, we aligned some of the
Is it just me that can't hear Harry, or other people can't hear
Yeah, I
him?
think we may have lost
It's
him.
gone.
Well, let's give it a couple seconds for Harry to come back.
significant megabytes per core. So that's what our goal is, to exceed and achieve and exceed that metric right there.
So, sorry, Harry, we lost you for last about 15 seconds or so. We came back on saying metric per core. So would you mind repeating the last couple sentences?
Okay, no problem. Yes, I do believe we got a network challenge here, but the metric that SAS gives to any customer is, we don't really give you any requirements other than you have to maintain an IO rate equivalent to 100 up to 150 megabytes, a minimum of 125 to 150 megabytes of IO throughput per core in your SAS compute environment. And I've got customers with hundreds of cores in their SAS compute environment. And if you translate that into an IO throughput rate, any customer that's using SAS that has, a large implementation is generally driving multi-gigabytes a second of throughput into the SAS compute. So, this is what our infrastructure and architecture and design has been focused on. The significance of doing that, I can give you an example with one of a published example. So I will name the client at the Bank of America, where they had a quantitative finance model that took over 100 hours to run. And SAS and IBM worked and re-engineered their environment here, put it on a grid, and beefed up. And this is going back, by the way, to the Power 7 timeline that I have on this foil right here on the left, and delivering the XIV storage back then. And we were able to take those run times down from 100 hours to 2 hours. So the significance there should be obvious, in that from a business perspective, being able to run a job like that, a quantitative finance model against all 9 million mortgage holders, for example, and produce a result in 2 hours, gives the user the ability to run multiple iterations of that in the course of a single day, versus having to wait multiple days for a single iteration to complete. And at the time, Bank of America did a press release, which is very rare in my experience with SAS, because of the significance of that achievement. And it was all essentially enabling the underlying infrastructure to support the amount of data that was being passed through, that they were having difficulties achieving that prior to. So we've carried that all the way through the product family. You can see as we go across from left to right, the IBM technology from I am a power specialist, and that's what I've been doing for 30 some odd years here in IBM, and close to 25 of them working directly with SAS. But as you can see, the technology has, shrunken significantly significantly from the 45 nanometer chip technology that we had in Power 7 to what we just delivered, within the past several months with Power 10, which is 7 nanometer. So we just delivered the first 7 nanometer commercial platform in the market, to my knowledge, and we are getting ready to bring SAS into our lab, to actually execute the test with the Power 10 and basically refresh our reference architecture. Our current point of reference for this goes back to the Power 9 family, which is the 14 nanometer chipset right in the center here. And we've got a solid reference architecture. To give you an example of our achievements, when I say SAS says, give me 100 to 150 megabytes per second per core, our reference architecture delivers 400 plus megabytes, and it scales linearly. So we have and this is part of what our testing and enablement with SAS is. We start with a very small subset, and then we scale it. So we started off in our testing with the Power 9 with a single compute tier with 18 cores. And at the end, we ended up having 4 compute tiers, or grid nodes, as they're commonly referred to, with each having 18 cores. And the total is, I think 72 cores of Power 9. And when you multiply that by the 400 megabytes of IO throughput, we were driving, IO throughputs in the 30 plus gigabyte a second range. And this is really where the value for SAS comes in. When we can move that data that quickly, then it really has a measurable impact on the outcome of these SAS jobs, which translates into a measurable impact to the line of business. So that's all I wanted to say on this one. You can see that there is a future. There's a power roadmap, an AIX roadmap, and everything associated with it that goes out for the next 25 years. We just delivered the Power 10 family in the past several months, and we're already working on Power 11. And when we get into these timeframes, this is generally where we engage with SAS at a very technical level and say, okay, what's coming down the pike that we can build into our next generation of processors that will help you, and our customers, achieve their business results. So one more facility, please, next.
Here you are. You should be able to see the slide now.
Yes. So, I'm not, this is a slide I could literally talk to all day long, but I will spare you folks and just give you a high level. This is an example of the kind of design that we come out of our testing at SAS and with SAS. And this is what, a visual depiction of what I just described to you that we built with our Power 9 systems and our all flash arrays with flash core technology. And this, as you can see, we have 4 LPARs. Those are 4 SAS grid nodes. An LPAR in an IBM world is just equivalent to a VM, and any other world is a virtual machine, and logical partitions are what run on AIX. And you can see that we had the Power 9 on the, driving all of this. We had, ample bandwidth from a fiber channel connectivity out throughout the infrastructure. We virtualize almost everything that we can in this environment. So you'll see a little block there called VIOS, which is our virtual IO server. And on the back, you'll see a depiction of what ends up on our storage environment, whatever it happens to be. And those are the key SAS areas. We have the SAS data, which is where we store our persistent data. And then we have the 2 areas that are commonly known as scratch areas, SAS work and SAS util-look. The SAS work is, it is a scratch area, but it is essentially where all of the processing, once SAS gets the data read in to its compute environment and starts executing on the logic flow, it is reading in files from the persistent area, the data space, and then creating multiple copies of those to do merges and joins and things along that nature. That SAS is, that's what the programming language does. And all of that stuff occurs into that SAS work area. SAS has several procedures, I'd say 10 or 15, probably at the most, that we call multi-threaded procedures. And they have a different, they have the ability to actually span across multiple threads of a single core. And the multi-threaded procedures actually trigger off similar kind of work activities as we see in the SAS work area in that util loop. So, and it's just an optimization technique that we use if we're doing a large volume of data. There's advantages to separating these areas out on your storage environment so that you're putting your SAS work in a separate file system than your SAS util loc, and all of that is separated both physically and logically from the actual persistent SAS data. And if you look as you go through to the right there, over there on the far right lower block, that is, our N-1 generation of our flash storage technology with flash core modules in that. And this is another significant game changer here. That little box is 2U. It used to take literally a data center to fill up multiple petabytes to deliver multiple petabytes of storage. We have the ability to deliver 1+ petabyte of storage these days in a 2U form factor. And this is blazing fast NVMe flash core technology that also has built-in compression capabilities that are offset. So it kind of eliminates the overhead of doing compression if you're doing it in SAS, but also from the actual utilization, the space utilization. When a customer buys a terabyte of space through the compression, we're actually delivering up to 2.2 terabyte of usable space from that 1 terabyte due to compressions. And SAS as the SAS data, the files that SAS generates, SAS data sets are highly compressible. We can see as high as 80% compression ratios. And the significance is, I've literally got customers that have generated a single SAS output data set that measured 80 terabytes in size. So you can understand the significance of all of that stuff when you consider the kind of volumes that we're dealing with in the SAS space here. So this is where we currently are. This is our current reference architecture. This is what I have running at most of our large banks and insurance companies across the globe. And like I previously said, we have just announced and are now shipping the Power 10 equivalent to this reference architecture here. So my next goal for the next month or two will be to getting back in the lab with SAS and the new IBM hardware. We have a refresh of the flash system. The flash system 9200 is our current product, which gives us a lot more capabilities from a throughput perspective, which is really where all of our goals and objectives are focused on. So we'll move the fabric to a 32 gigabit fabric from the 16 gigabit fabric that's shown on this foil right here. And the processors, the Power 10 processors also will come with another 30+% boost in performance. So at the end of the day, I would anticipate that where we were seeing like 400 megabytes per core of IO throughput that was driving into the SAS compute area. With Power 10, with Power 9, the only constraint we had was the IO bandwidth. At 16 gigabit, we totally saturated 16 fiber channel cards. That's how we got to 30 gigabyte of throughput. But we'll have the ability to exceed that by a factor of 2 or more X with the 32 gigabit fabric. So this is what the goal going forward is, to get into the lab, to prove that out, to reproduce the reference architecture, which, by the way, folks, you don't have to, all of the stuff that we do, one of the main things that I, really strive to achieve is that we make this very easily findable. So you can just go into any, browser and Google SAS on Power 9 or SAS on IBM storage, and you'll get direct links to these, what I call performance briefs that we produce. And, you can do that going all the way back to, 20 years of our work with them. There's, documentation out there over that whole period that shows kind of like the linear, progression that we made over all those years with the technology. So, I guess to wrap this up and to, leave you with a thought here, SAS is a very, very powerful tool. It, can definitely generate some challenges when you have jobs that have tight service level agreements or SLAs, and certain things happen through the SAS processing that cause the SLAs to be missed. And in my experience, when these SLAs are missed in the SAS world, it does not take long to start escalating and wind up in the ivory towers. And depending on the severity of it, I mean, if we have an outage that's measured in a day or more, we're doing regular reporting on an almost an hourly basis. So, the part of one of the reasons customers are really buying into this design point is because the Power Platform is historically a very reliable platform. I've never had a customer tell me ever that they've had, a significant amount of unplanned outage in their environments that run on Power. So this is, essentially the message. Getting SAS optimized is a combination of several things. A lot of it really does fall in the actual logic that's coded, the programs that are written by the SAS users. But in addition to that, the underlying infrastructure is a critical piece to achieving the capabilities that we're discussing right here. So I'm going to just stop it at that, Vasily. And then if there is any questions, I'm happy to entertain. I keep getting flashes on my screen here about poor network connectivity. So hopefully this is all coming through.
No, we could hear you very well for the last, absolutely. So I would like to open it to the floor, and indeed, that has anyone has any questions for the next few minutes? You, Kate, go ahead.
Hi, thank you very much, Harry. That was very interesting. When do you anticipate getting into the lab?
I'm actually heading up to our lab center next week to start building and putting together the pieces that we'll need to do this. So my goal is by, early to mid first quarter of next year, we'll have the Power 10 and the latest all flash with the latest spectrum scale, which is, to folks who have familiarity with the product, is what we used to call GPFS. And almost every SAS grid, there's thousands of them deployed, and I would say 90% or more of them rely on, spectrum scale GPS for that. So the testing I'm hoping to have done in January to February.
Excellent. Thank you very much.
Anyone else has any other questions? Harry, on your previous slide, there was mentioned memory clustering, and I already attended a couple Power 10 presentations delivered by IBM in other meetings. So, but I want to get your perspective. Could you explain a little bit more on the memory clustering that Power 10 brings to the architecture?
Well, what I can say, because, I'm not the chip designer, but I do, I have heard of this. And when we, long before we, announced Power 10 as being available, we were in SAS multiple times for multiple hours doing an NDA presentation. And I will tell you that one of the main things that surfaced out of all of that discussion was this OMI, open memory interface, that we're introducing with Power 10. This to getting into what the full explanation of how OMI works, I'm probably not the right guy to do it, but I will tell you that, SAS, in addition to being IO dependent, also, the real benefit to SAS is you know, how much you can get into memory, and the few knobs that SAS does provide the user environment, the user community, are things that allow you to define the mem size, for example, or the buff size. So the IO block size is the buff size, but the actual memory, maximum memory size is the mem size. And, you know, there are techniques that you can use to increase that parameter mem size to have all of your data read into memory and not have to go back and forth and do the IO. But, you know, and that's where the advantages are going to be seen, I think. Not only that, but we have a larger L3 cache, and I think even extended it out to an L4 cache. So in the actual data processing, the number crunching, that's where the significance of that OMI feature will come in. And what I do expect to do, Vasily, is when we get into the lab and test it, we are going to break out the OMI as a independent appendix or something like that to focus on what the delta between the traditional memory architecture and the new memory architecture is.
Got it. Thank you very much. We still got a few more seconds for any other questions. And if there's no questions, I'll start closing the call. Any other questions?
So apologies for all of the glitches here. I'm glad that I was able to get in, and I saw a few people had to drop, so that's unfortunate. But I'm always available, you know, if there's any questions or anything like that. You know, if my email information isn't here, is certainly available to the folks that are hosting this call for us. And I'm happy to have a follow-on discussion with anybody that would like to.
Absolutely. Thank you very much, Harry, for finding the time. I appreciate getting up so early, get into the call. Thank you for the slides. And to thank you everyone else for coming over. And Alan just posted again a Meebo link in the chat. Do jump onto that, to the virtual room, where you can also carry on the conversation and discuss this or any other topic further. This recording will be published on our usual YouTube channels, and the links posted across the social channels as well as in the meetup in the next couple of days. Again, thank you very much, everyone.
Thank you.
Thank you.
Thank you, folks.
Thank you. Have a good one.